All right, so as for today, gonna finish up this lecture again. Shouldn't take too long. And then the rest of the day is just activities, any questions you have. Because on Tuesday, we have the chapter 5, part 2 quiz. And then we finally start chapter 6 is when it gets really good. Okay, so just to be aware, those solutions are posted online, right? Did everyone at least see that?
Solutions
To the quiz.
Oh.
Yeah. All right. So definitely, because when we start doing the stuff in chapter 6, all that stuff we did in the first half 5, I mean, it all just keeps building. So you definitely want to make sure that you see what you did wrong and all that good stuff. All right. Okay. You okay, Brenna?
Feeling rough.
Feeling rough? All right. Hopefully you don't have to power through for too long. Okay. So we have a graph cosine, and we see first thing to identify, it has a negative sign, which means we're going to flip it at the end. And actually, this one has something else interesting going on. So we have a negative in here. And this is finally where we get to use, all right, some properties, because that negative is kind of messing me up. I don't know what to do with a negative omega equals -2. So let's pull that negative. Actually, while we're at it, let's just pull the -2 all the way out. X becomes minus pi over 4, because it's just dividing. So this is where we actually finally get to use the even and odd properties while graphing, because the graph of cosine, its fundamental principle is that it is an even function, right? It mirrors across the y-axis, which means that that negative actually goes away. Which is good because I don't know what to do with a negative omega. And similarly, if it was odd, if this was sine, I'd pull it all the way to the front. And actually that would make it even better because then I wouldn't have to flip the graph at the end. So now I actually have something that I can work with, and I can start identifying my pieces. So easiest to identify, A, the amplitude. -3? Just 3, right? I was like, amplitude, we always just go up and down, so we don't really worry about the sign there. It's kind of an absolute value, actually, because we just know it's a distance. All right, let's see what else is super easy. B. That is the y shift. What's the y shift here?
-1.
-1. All right. And then phi all over omega. I know the notation is not great, which is why we just call this the x shift or phase shift. What's the phase shift here? Pi over 4. And that's pi over 4, right, opposite sign. All right, and lastly, omega, which we've said already multiple times, is 2, which we use to find the period. Oh, and a nice easy period pi. Actually, we have pretty good numbers here. Pi over 4 and period of pi should be actually make identifying our values relatively simple. So when we're about to go into graph now, we can actually start identifying our 5 points. The start point, which is equal to the x shift, which is pi over 4. The end point, which is just start plus the period. And are we getting better at this math? What's pi over 4 plus pi? That is, what is 1 plus 1/4? Charlene?
Just without the pies,
Yeah, without the pi's.
that'd just be 1 and 1/4, so 5/4.
5/4, right? And this is the start of upper division math. We don't write mixed numbers, right? So everything is always improper fractions because we have to turn this back into 5 pi over 4 or 5/4 pi. Right? And that's the easiest way. Drop the pi's, add the numbers, put the pi back in. All right, and then we can do the halfway math, but this is also something that we might be able to just see. Halfway, which is start plus the end divided by 2. Let's see if this gets worse. Let's see. So we have pi over 4, bless you, plus 5 pi over 4. So let's see, 1/2 times 6 pi over 4. 3 pi over 4, which is what we expected that to be. Halfway between pi over 4 and 5 pi over 4 is 3 pi over 4. First quarter and third quarter. Halfway start plus half. And 4 pi over 4 times 1/2 is pi over 2, which is actually 2 pi over 4. And oh my gosh, I think we can just guess what Q3 is. What's Q3 going to be? Do you see the pattern? This was 2 pi over 4. So I have 1 pi over 4. 2 pi over 4, 3 pi over 4, and there's 5 pi over 4. What's the missing one? Pi, aka 4 pi over 4, which is just pi. Right? And we could have done that from the beginning. All right? But, all right, absolutely skip these steps if you need. All right? They're there just to make sure because, again, that pi fraction math, right? It gets in your head. So, hold to the math if you need it, and if you can see the shortcut, take the shortcut. All right, we saw some other ones where they were just horrific numbers and the math is definitely helpful, right? But something like this. Okay, so I have all my points. All right, we've identified all information. Let's see if we can't graph this thing. Okay, so let's see, we start at pi over 4, so we're all in positive. All right, and we're shifted down 1 and over pi over 4. And then what's the approximate shape of just the first period of the cosine graph? I mean, that's true for all of them. The first period of cosine though looks like what?
Like a W.
Like a W, right? Or even a U, really, right? I was like, yes, absolutely. Okay, so that means our first point actually starts at the peak. All right, so the other big thing that might be helpful to do is identify, all right, if this is our baseline. So our baseline is actually, all right, that -1 line, because the whole thing shifted down 1. I need to go up and down from that baseline, the amplitude. So how far up do we go?
Oh, 3.
We go up 3, up 2, specifically 2. Darn it. Up to 2. And similarly, we go down 3, down to -4. All right, so we have our maximum and minimum now defined. And now we can start plotting points. My first point starts up here. Actually, let's draw. Okay, so pi/2, 3 pi/4, pi, and 5 pi/4. Since we're all shifted, let's identify points. All right, so my first point, I start at the peak, and then, all right, cosine dips through the x-axis in its normal graph, but now our new baseline. So actually, the second point is right here at pi/2, -1. Then it dips down to its minimum, which goes all the way down to -4. Then it comes back and then hits its maximum again. And that should be the graph of y equals 3 cosine of 2 x minus pi/4 -1. But again, what we actually needed, that's why I always make a note of it immediately just to remind myself, okay, am I done? Oh, wait. What's the one last thing? Flip it, all right? It's super easy to forget. You're like, we just did all that work, and I gotta remember that I need to flip it. And so now same thing, and the points are very similar, just in reverse. And once we have it flipped, then we have what we were actually looking for, which is the finished graph. All right, beautiful. All right, one more. One more, yeah, last one. And a couple things going on here. So first of all, I have cosecant. When you have cosecant, that means what do we need to do? Graph its reciprocal. Okay, so cosecant, I don't know what that thing looks like, but sine, I do. And we have a few things going on here. Amplitude. 2. All right. B, which is the y shift, which is And then actually, I see some really good news. Phi over omega, which is the X shift, is no shift. It's 0, right? No shift. Oh, okay, good. So we don't, actually, the good news is, all right, what we're not moving over, which means we're starting, all right, on the y-axis. So that's excellent news. We do, however, have an omega, which means our period is adjusted. But hopefully this shouldn't be too bad. Oh, that wasn't too bad at all. All right. Instead of a normal period of 2 pi, our period is 6 pi. So everything is actually just stretched out. All right, so our start point is 0. All right, and FY is the X values in case, just for emphasis there. It was obvious, but all right, the end point is the length of the period, 6 pi. And this is the one where we should be able to do this kind of quick. Because when my start is 0 and my end is 6 pi, I can identify these pieces pretty fast. What's halfway between 0 and 6 pi? What is it? 3 pi. All right. What is a quarter of the way between 0 and 6 pi? Or 0 and 6. What's a quarter of the way through 0 and 6? Or halfway between 0 and 3? 1.5. AKA 3 pi over 2. And back to what is halfway between 3 and 6? 4.5, AKA 9.5 pi. Ah, see, so boom, so you can do those pretty quick when they're nice numbers. All right. Okay, so we have all our values. Let's see if we can't graph. This was shifted down to an amplitude of 2. Okay, so we got all our values identified, our 5 points. All right, we are graphing sine. The entire thing is shifted down -2. So again, that realigns our x-axis to this line. And then, all right, we graph sine, our sine function, starting at 0, 0, but now 0, -2. Oh, and sorry, while we're at it, let's put the amplitude on there. All right, the amplitude is 2. So the maximum value, all right, from -2, it goes back up to what number? 0. And then it'll go all the way down to -4. All right. So the whole thing actually here is in quadrant 4. Okay, so for the standard sine graph, this thing isn't flipped. So for the standard sine graph, that starts at the point 0, 0, but now it's 0, -2. Then a sine graph hits its maximum at the first point, which is now up here. Then it comes back down, crosses through the x-axis, hits its minimum at the third quarter point, and then goes back to the x-axis. So that's why I like a sine graph. A sine graph is one, I mean, we graphed one period, but a sine graph looks like a complete period versus the first period of a cosine graph. Okay. So that is sine y equals to sine of 1/3 x minus 2. But again, not what we want. We actually want y equals to cosecant of 1/3 x minus 2. So we have some other values, and wherever the sine is the reciprocal, wherever it is crossing through its new x-axis, that becomes a vertical asymptote. So my vertical asymptotes are everything where my new axis is drawn. And then the cosecant graph, all right, is basically a bunch of parabolas mirrored off of the sine graph. Now, here's the other big thing, and this is your calculator is there to help you. It can't do everything, and it really has a hard time with this. But some tricks to make sure you're on the right path. Plug in your equation, okay, y equals 2 cosecant 1/3 x minus 2 into your calculator. Then you go to second calc value and put in a value you know where it should be. For example, you put in 3/2, and it should result in the value 0. Right? You know, like put in the value 3 pi and it should give you -2. And so those are the ways that you use your technology to check the math you did. It shouldn't be black box. The calculator is there to help you. And if the calculator, I mean, I'm all about using the calculator to graph. It doesn't graph this stuff well, right? Which is why we need to understand how to do it by hand, right? It'll make a graph and it'll go on forever and ever. But I mean, you don't know what the scale is, you don't know what it looks like. That's why we need to make sure we can graph these, right? The calculator then can assist you of what you're looking for later down the road.
So when we're doing, like, if we have to do something like this on the quiz, since we don't have multiple colors to write with,
Just
do you
point.
want us to just put the y, like, just on one of them, right? Not on all of the,
But well, I mean, I still graph it like this, I just point.
yeah, but do you want us to point to to both of them, or just,
Oh, and point to this one up here.
or just the one?
You can just point to one of them, and ideally I know that as long as you understand that the other one is the cosecant,
Okay,
and then yeah, and that one is the sine.
okay.
Like, yeah, I mean, that's all that you need to do, because I was like, at this point, this demonstrates understanding that you know what's happening. All right. Any questions? All right. There are 2 wonderful activities, right, for chapter 5, part 2. Right? Any questions you have, if you want to hang around, I'm happy to answer those. Otherwise, you guys have yourselves a wonderful weekend. And what are you going to do this weekend?
Home fun.
Drink
Home fun? What else?
activity.
And one last.